Your name correctly. Fareed Hekmat, is that correct?
Yeah. Perfect.
Okay, good.
Yeah.
I'm going to flip your collar back. You're on TV there. Can be as disheveled as you want on the radio.
Well, for us, we are on radio. So, yes, whenever you're ready.
Yeah, recording, so whenever you guys want to start.
Okay. Good morning. This is Tim Cromartie from the League of California Cities. This is the second installment of a series of 3 webinars that we're hosting on oil by rail safety. Today we're going to delve in detail into the federal issues, the laws and case law and regulations that apply to the transport of crude oil by rail. Our speakers today are Michael Cavanaugh and Fareed Hekmat. Michael is a partner in the Holland & Knight Washington office, a Stanford Law graduate. He specializes in transportation and infrastructure development and regulation. He represents railroads, shippers, and governments in rail mergers and acquisition transactions. He also advises industrial shippers on rail and intermodal service agreements and assists transit authorities with the regulatory issues such as abandonment and conversion of rights-of-way to commuter lines. He has also advised governments of developing nations in Africa on rail privatization and development of rail operating regulations. Mike has firsthand operating experience working during his college years as a brakeman on the New York Central. Fareed Hekmat is an associate in the Holland & Knight Washington, D.C. office, a Vanderbilt Law graduate. Fareed assists multimodal carriers and shippers with commercial transactions, intermodal project development, and federal transportation and regulatory matters covering rail, truck, water, and intermodal shipping and logistics. A couple of housekeeping issues before we get started. We're going to allow both verbal Q&A as well as typed questions. For verbal questions, please click on the hand icon on your computers and wait to be acknowledged for the Q&A period at the end of the program. You also have the ability at the bottom right of your computer screens to type in questions for the Q&A. So with that, I will turn it over to our speakers.
Thanks, Tim. This is Mike Cavanaugh, and it's a pleasure to be here, and we hope this will be helpful. We'll reserve plenty of time at the end for the Q&A, and we'll go ahead and proceed into our program now. We're going to open with a little bit of historical context and then get into how the current federal regulatory scheme works, and then we'll proceed from there into the preemption issue, which largely dictates what states, cities, and other non-federal jurisdictions can and cannot do in the area of regulating rail environment and safety. And then we'll get into a little bit more detail on that subject, and at the end try to focus on what types of areas or possible solutions could cities come up with if they want to regulate in this area. What's the safe zone and what's not allowed. So starting off here, we have a little bit of historical background. I think as Tim mentioned in the first installment of the webinars, oil transport by rail is not a new thing at all. In fact, during World War II, there was an enormous volume of oil moving on the rails. Prior to the war, oil came out of the Gulf and was shipped by tanker to East Coast refineries. Once the war started and the German U-boats started picking off tankers, the government tried to move all that traffic to rail, and the rail lines were really jammed up with unit trains of crude oil moving throughout eastern cities. It all seemed to go pretty well. There were issues and accidents. Of course, in those days, a typical train was moving 10 miles an hour and was probably 50 cars long because steam locomotives couldn't lift longer, heavier tonnage trains up over the grades in the Alleghenies. We've seen a tremendous growth in traffic in crude oil originations just in the last year. We've got one statistic there saying in excuse me, 2009, there were only 10,800 carloads. Last year, it was up over 400,000 carloads. A lot of that moves in unit trains, and for background, a unit train is basically designated as a train that consists of generally all one commodity and all one type of car. So typical oil unit train might be 75 to 100 or more tank cars of crude oil with no other manifest cargo in there. The advantage of the unit train is it can move over long distances with no switching out of cars. The train doesn't go into the marshaling yards at each rail junction to be reconfigured. They keep the locomotives on and just change crews at the division points, and the train can move through with a minimum of cost and delay. Interestingly, there have been very few accidents in the United States. There have been some. The accidents have gone up as the volume of oil shipping has gone up, but overall the rate of rail accidents has gone down, so the figures kind of work in conjunction with each other. But it's not been a major source of accidents or death, destruction, and environmental harm, but when it happens, it's bad, and the potential is there for large disasters. I'll turn it over to Fareed here to go through the federal regulatory scheme here, starting with slide 3.
Thanks, Mike. Good morning. This is Fareed Hekmat. As the first webinar mentioned, regulation of both rail and generally hazardous materials is through the federal government. For hazardous materials, and both of the agencies are in the DOT, U.S. Department of Transportation. For hazardous materials, the primary agency is the Pipeline and Hazardous Materials Safety Administration, PHMSA, and they've set out the hazardous materials regulations, the HMR, which cover the storage and the transportation interstate of hazardous materials. For railroads, the primary agency is the Federal Railroad Administration, the FRA. The FRA was created in 1970 with the Federal Railroad Safety Act. Prior to that, railroad regulation was done by the Interstate Commerce Commission, which itself was abolished in, I believe, 1989. The FRA is responsible for and promulgates nationwide rail safety regulations. It regulates rail infrastructure, and it regulates rail operations. On this slide, we see some of the types of regulations that are covered with railroads. For example, state safety participation. This sets out when state agencies can investigate railroad accidents and what kind of information exchange there can be between states and federal authorities. There's track safety standards, which talk about track geometry, track structure and inspection, railroad operating rules, railroad operating practices, railroad communications, radio and wireless communications, rear-end marking devices, which regulate displays and inspection procedures, hours of service railroad employees, which pertain to maximum working hours and the sort of record keeping that's required, railroad locomotive safety standards, railroad safety appliance standards, brake system safety standards, signal systems reporting requirements. This is just some of the areas where the federal government has already promulgated regulations.
Let me note right here, we didn't include in the regulatory description the National Transportation Safety Board, which I think, as everyone knows, investigates accidents after they happen and makes recommendations. So we're covering the upfront, proactive, ongoing regulatory schemes of the DOT here.
The hazardous materials regulations cover hazardous materials. Hazardous materials are defined and listed in different places in both the U.S. Code and the Code of Federal Regulations, primarily in 49 U.S.C. Chapter 51. Section 5103 permits the Secretary of Transportation to designate as a hazardous material any substance or material that is capable of posing an unreasonable risk to health, safety, and property when transported in commerce. hazardous materials include explosives, radioactive material, infectious substances, flammable or combustible liquid, solid, or gas, for example, petroleum, gasoline, ethanol, toxic, oxidizing, or corrosive material and compressed gas, marine pollutants, and elevated temperature materials. Under the regulations, crude oil, including crude oil that's being transported from the Bakken reservoir, is considered a Class 3 flammable liquid.
Okay, getting into the hazmat regulations, and just for those of you who aren't familiar with crude oil or haven't worked with it, unlike diesel and some of the refined products, what you're actually, believe it or not, relatively hard to set on fire with a match. Crude oil ignites very readily, and at normal room or atmospheric temperatures, it gives off a vapor which will ignite if exposed to an ignition source like a spark.
And especially the crude oil from Bakken is considered a light sweet oil. It's light in that its flash point is relatively low, and it has low sulfur content, so it's more flammable than, for example, a heavier sour crude.
Okay. The DOT hazardous materials regulations, which we start to cover here, and we'll try to go through this quickly. Who does it apply to? The first category is anyone transporting hazardous material in commerce, which would be a railroad, trucking line, barge line, or any carrier that's moving it, as well as a pipeline. The second category is anyone who causes the material to be transported, which would be the shippers, which could be the, depending on the form of transaction, it could be the oil major or the producer at the wellhead, a middleman, or a refinery. There's probably a lot of categories. Whoever is basically the shipper of the oil. Third category is anyone who designs, manufactures, makes, inspects, repairs, or deals with generally any container packaging or equipment, and that would include rail car manufacturers, leasing companies who own most of the fleet of tank cars that are out there, as well as car repair companies. The other categories are anyone who prepares or accepts hazardous material for transportation and commerce, which could be a bulk terminal or a freight station. Anyone responsible for safety of transport materials in commerce, which could be, I'm really not sure, but probably a third-party contractor in the security space. And then finally, any compliance or certification agencies, which could be anyone who's setting standards. Moving on to what the hazmat regs actually do. The labeling regulations, this is a very big part of the DOT scheme, making sure that the hazardous materials which are being moved are properly labeled so that everyone who is around them knows they're there, and that includes properly manifesting them and doing the paperwork to reveal what they are, as well as putting labels on packages and placards on tank cars and conveyances. Need to move that ahead. With respect to carriage by rail, the principal CFR parts of the PUMSA, the Pipeline and Hazardous Materials Safety Administration, requires that all shipments by rail conform to their regulations, and subpart 24 says a person may not accept hazmats for transportation unless that person receives a shipping paper prepared in accordance with Part 172. So that's the documentation requirement. The next portion of this deals with notice to train crews. The regulations assume it's critically important that the train crew know what materials are back in the train, which would be information about what those materials are, what particular hazards are presented, and then additionally where they are in the train. you know, a mixed freight train can be a mile long with more than 100 cars in it, and the crew usually just picks that train up in the yard and couples onto the front end of it and doesn't walk the brakes or walk back and see what's there before they leave. So they're relying on this printout to tell them what's there and where those cars are in the train. So if they have an incident or a derailment, they'll know what to be looking for. The next part of it is a chunk of the regulations that deal with tank car unloading, because there are a lot of spills and hazards that occur there, as well as risk of explosion. So Fareed, what is the braking portion of that intended to cover?
The braking portion covers
I believe it
requires the person who's responsible to apply the handbrake and block at least one wheel to prevent movement in any direction.
Right. Just for those who haven't worked with railway equipment, all cars are fitted with the Westinghouse air brake system, which is under which the brake shoes that put friction on the train wheels are applied by air pressure in a reservoir that's like a big tank underneath each car. So each boxcar, gondola, tank car, whatever type of car it is, has exactly the same equipment. And the locomotive provides air pressure to keep those reservoirs full, and the reservoirs apply the brakes when the pressure is below 80 pounds per square inch. If the engineer pumps that pressure up above 80 pounds for freight, then the pressure above 80 pounds goes on the backside of the brake piston and releases the brakes from the wheels. But when you put a car in a siding or at a loading or unloading point, you would uncouple the air hose and let the pressure out of the air system, so the air in the reservoirs would tightly set the brakes. But that air can bleed out if that car sits there for a long time. And also the yard crews sometimes bleed the air out to let the brakes hang free to move the cars around with their switching engines. So you also would set a handbrake, which is it looks like a little steering wheel that's up on the ladder, and you go up and you crank it tight, and then it just mechanically pulls a chain that pulls the brake shoes tight against the wheels. But of course, that's just human pressure. You know, even the strongest person probably couldn't get anywhere near as much pressure on those brake shoes cranking that wheel as the air brake system could. But anyway, you want the brakes set when you're loading and unloading so the car doesn't suddenly move and then cause a spill. But the rest of this section of the regulations is just designed to make sure that when people are loading and unloading the cars, they avoid spills and ignition sources. You can't smoke around there. You can't be running an internal combustion engine or any other source that might torch off this very dangerous material. Next section here, subpart 300, or special handling requirements. This really just applies to tank trucks that are set up on flat cars, and that's not how this commodity moves, so I don't think we'll spend much time there, but it's, again, to prevent dangerous possible ignition sources and things like that. And we'll try to move quickly through the rest of this because this stuff is about the most boring part of the whole thing here. Key thing under the PUMSA regulations is that they also provide specifications for tank cars. Is this thing stuck? Okay, got it. And what DOT does is they have a set of standards for tank cars that are designed to reduce the likelihood for spills, accidents, and explosions. Interesting thing to note, none of these really has anything to do with the likelihood of that tank car derailing. There's the undercarriage of the tank cars and the wheels, the trucks, the braking system on a tank car is just the same as it is on a covered hopper or a gondola or any other type of freight rail equipment. And that car does not have anything special down there to reduce the likelihood of the derailment. And we'll come back to that in a little bit. But DOT some time ago, together with the Association of American Railroads and the car manufacturers, and probably with a lot of input from all levels of the industry, came up with an approved design called a DOT 111. And this is a tank car that carries 34,500 gallons, and that's about something around 145 tons of cargo. I did the math before. I forget how many barrels it is, but the numbers are down here on this page. The key elements of that regulation are, again, designed not to prevent derailments, but to reduce the likelihood that the tank will be breached and spill its cargo or ignite if a derailment does occur. So first thing is the steel thickness of the tank is 7/16 of an inch, which is a very heavy gauge of rolled steel. The type of steel and the quality are specified. The couplers and drawbars, which are the draft gear on the front and rear of the car. Actually, a car doesn't have a front or a back. Both ends are identical from the coupling side. That's the coupler glove and knuckle that couples onto the car ahead or behind in the train. And the draft gear is a long box-like structure, about 4 or 5 feet long, that's got springs in it, meant to absorb the shock of the train pulling out when the train starts up, or when the slack runs in and bumps up against the locomotive going downhill. And what this regulation does is creates a design for the car such that if there is a collision or a derailment and that car slams into an object in front of it, like the locomotive or the car ahead of it, that big steel apparatus will be forced down underneath the car rather than upward puncturing the tank. And that's kind of the key element of it. I think the DOT 111 has been around for quite a while. I've found references to it going way back before 1990. But there are still, there's actually 1 or 2 higher rated types of tank cars out there. There's a DOT 112 and a DOT 114 that actually are more robust against puncturing and explosion than a DOT 111 is. Those are required in the U.S. and Canada for use for transport of hazardous flammable gases, and they're generally pressure tanks, so the gas is in there under pressure. Obviously, you want have a very high standard for protection against rupture there. Other DOT regulations with respect to these cars call for improved protection of the top gear, which is the tank head and the loading point and discharge points of the car, where the valves and pipes that go in to load and discharge the car. Other elements covered are the tank compartments if the car has multiple compartments on it. The welding standards to make sure that these cars are built robustly. Expansion capacity, which is, I think, covers damage that can occur from heat and cold because where the steel and the joints expand. The gauging devices, venting and air inlet devices to prevent explosion from pressure. With tank cars with crude oil, you've also got the fumes and gas, the gaseous version of the crude oil and natural gas liquids that are dissolved in it and distillates that are in it that forms up in the ullage above the liquid part, and that's actually a big explosion hazard, and these devices deal with that. Also, there are regulations on lined tanks, so very comprehensive regulations, but again, they're designed to prevent spills and ruptures in event of a derailment or collision, but they don't per se protect against a derailment itself. Let's turn quickly to the role of the Association of American Railroads. This will sound a little bit like a commercial for them because we basically plagiarized a chunk of this off of their website, but it is accurate information and good factual background. But this indicates that there are 335 tank cars out there in the North American fleet. 228,000 of them are DOT 111s, which we've just talked about. And there are 92,000 of those that are used to move flammable liquids such as crude and ethanol. And but only 14,000 of those are built to the latest industry standards. There was a tick up in the industry standards following a derailment in Cherry Valley, Illinois. I think it was in 2008 or 9, where there was a lot of crude oil spilled, and I think it was more of an environmental disaster than a human death and injury tragedy. But the AAR and DOT both took a look at what was going on with these cars, and they've recommended certain changes, in particular going from 7/16 up to 1/2 inch gauge steel for the tanks, which gives better protection against rupture and breakage in a derailment. They've also recommended improved protection for the top gear. They note here railroads generally don't own these tank cars. They're largely owned by leasing companies that operate enormous fleets of them under tax leasing arrangements. And you'll recognize names like GATX, Railmark, which is a Citigroup affiliate, is a major lessor, and there are quite a few others. These are very big, generally considered financial institutions rather than operating companies. And they're title owners of these cars and lease them to the railroads on various forms of leases. You'll note that AAR has a tank car committee. It's comprised of the association, rail car owners, manufacturers, hazmat customers, active participation by DOT, Transport Canada, and the NTSB. So it's a sort of a cross-industry group, and they have tended to promulgate recommendations and regulations which are somewhat stricter than those actually published by DOT from time to time. So they appear to be out ahead of the curve somewhat, but of course we'll note that you know, it is basically an industry association, and you know, whether they go the full length that cities or environmental groups or other interest groups or unions or anybody else want to do is always under debate. The Tank Car Committee works to develop technical standards, and they've adopted, as I mentioned, these higher standards for the DOT 111 cars in October of 2011, and that followed that Cherry Valley accident and a comprehensive study done there. Then in November of 2013, the AAR again opened up this subject and is again urging an increase in federal tank car safety, requiring these cars to be built to a higher standard or retrofitted or phasing out the old ones. And at this point in time, there are the association indicates there are 92,000 tank cars moving flammable liquids, including crude oil, and 78,000 of those, as of this point in time, will still require that retrofitting or phase out. And then there's 14,000 of these newer cars that are out there. So, and it's interesting that there's a lot of software that goes into selecting cars to make up unit trains. It's really quite an art, but when a dispatcher has to gets a call, for example, to send 200 or 300 tank cars to a crude oil supplier depot to get loaded, that dispatcher might have, you know, maybe as many as several thousand tank cars available at the various storage yards and locations that he could dispatch over there. They use sophisticated software that's proprietary to the railroads to pick the cars that give them the best deal on the leasing. In other words, certain cars are per diem cars where you have to pay rent to the lessor whether the car is running or not. Others are you pay only when the car is loaded and on your railroad. There are also free-running cars that are charged out differently. So it's a mind-boggling exercise to pick the best economics when you put a train together. But at this point, as far as I know, the software does not look at the safety rating criteria in making those selections. AAR has also offered some additional safety measures such as full height head shields to protect cars in collisions, better valves, and thicker jackets. Again, we'll note that these cars with these better features are not particularly less likely to derail. Derailments are caused by other factors. They're less likely to rupture and spill or explode if they do get in a derailment. Okay, I'm going to turn it back to Fareed here to get into the preemption subject.
Okay, under U.S. law, federal laws trump any state or local regulations if they come into conflict. Frequently, litigation is whether federal law preempts the state or local regulation. However, for railroad regulations, the preemption is explicit. In Section 20106, it says that laws, regulations, and orders related to railroad safety and railroad security shall be nationally uniform to the extent practicable. This means that federal law does indeed trump state and local regulations. However, there is a savings clause, and the statute provides that a state may adopt or continue enforce a law, regulation, or order related to railroad safety or security until the federal government prescribes a regulation or order covering the subject matter, so long as these three criteria are satisfied. One, the state order or regulation is necessary to eliminate or reduce an essentially local safety hazard. Two, the local law or regulation is not incompatible with a law, regulation, or order from the federal government. And three, the local law or regulation does not unreasonably burden interstate commerce. Almost all litigation regarding state and local regulation of railroads has involved the issue of whether there exists an essentially local safety hazard requiring additional state regulation. The burden is on the party claiming preemption, and although preemption is written into the statute, courts have a presumption that preemption does not apply for federalism issues. So we're going to discuss a few cases that have talked about this essentially local safety hazard. The first one is the City of Shakopee case. This is an interesting case. The town of Shakopee had provided a railroad a right-of-way in, I believe, the 1870s for a railroad track that runs through the middle of the city, essentially through the central business district. And within one particular section that's about a mile long, there were 10 grade crossings along with the eastbound and westbound lanes of one avenue being divided by the railroad track. So drivers would have to cross the railroad track and still have to look for the other side for traffic. There was a number of there was a combination of warning devices and other safety measures, but there were no automatic gates with time circuitry and no automatic flashers with constant warning time circuitry. After 6 accidents within 5 years, the Minnesota Department of Transportation decided to set a speed limit of 10 miles per hour for that portion of the track. The court looked at the regulation and looked at the federal rules and decided that the local regulation was okay, that it fit within the exception. The court's analysis focused on what constitutes an essentially local safety hazard. And the city, the Department of Transportation had set out 5 factors it considered as creating that local safety hazard. 1, that the track ran down the middle of the city. 2, that it had 10 grade crossings within only 1 mile. 3, that there was a high volume of pedestrian and vehicular traffic. 4, that the track ran in close proximity to both road traffic and buildings. And 5, and this is very important, that this was the only place in the entire state of Minnesota that had this unique combination of factors. So the court wrote that these factors, coupled with the truly distinguishing characteristic of a track that runs between opposing lanes of traffic down the middle of a downtown street, qualify this as an essentially local safety hazard within the exception. The railroad argued that the town had a host of other options to address the problem, but the court held that just necessary to eliminate or reduce the hazard did not mean that it had to be absolutely necessary, giving states and localities some leeway in addressing these sorts of hazards. However, this is kind of a unique case. In Union Pacific Railroad Company versus California Public Utilities Commission that was briefly discussed in the previous seminar, following the Cantera loop derailment, the CPUC identified 19 sections of track that they said posed a local safety hazard and promulgated a host of regulations for trains traveling through those sections. This included train configuration based on track train dynamics, which is how railroad cars are joined together. For example, the heavier cars being in the middle or the heavier cars being towards the end. They also wanted standards for dynamic braking systems.
Let me just quickly explain that the dynamic brake, in addition to the air brakes, which push composite brake shoes against the steel rail wheels to slow down a train, dynamic brake is in the locomotive, and what they do there is they reverse the electrical field of the traction motors. The diesel engine spins a generator which makes electricity, which runs motors on the axles. You reverse the electrical field in those motors to make them into generators, and then they generate electricity which is dissipated in the form of heat in coils up on top of the locomotive. So it's a powerful braking mechanism, but it only slows down the wheels of the locomotive. And what happens with these track dynamics is if you had a bunch of heavily loaded cars back in the middle or rear of the train, and then lightly loaded cars at the front of the train, and you're going around a curve, that weight running in against the locomotive could buckle the cars up front and flip them over, flip them up, or push them out to the side, causing a derailment. And then just while I got the mic here, just below that you'll see a reference to the end of train telemetry devices. And that's a box that's fitted and strapped onto the rear drawbar of the last car of the train. It has a flashing light on it to signal the rear of the train for safety purposes. It also is connected by radio to the locomotive and can be connected into a positive train control system. And the last air hose on the train is also coupled onto an air hose to the ETD, so that the device in there can be activated from the locomotive to set the brakes from the rear of the train. Sometimes that's necessary if, as we used to call it, if somebody angle cocked us, which is when you're proceeding really slowly, sometimes kids or vandals or whatever would run out and reach in between the cars and close an angle cock, cutting off the locomotive's control of the air brake back through the end of the train. With this, you could set the air on the rear of the train from the front end.
Additionally, the regulations wanted to institute new training programs and to heighten standards for securing standing trains. The court, this here was the Ninth Circuit, which covers California, looked at the regulation, and their analysis, again, focused on whether these 19 sites were essentially local safety hazards. And the court's inquiry said that the nature of the hazard itself determines whether this is one that has to be dealt with on a local level. And for that to happen, the hazard must be one that cannot be adequately encompassed within national uniform standards. It's important to note that a hazard cannot be statewide in character. For example, although Site 9 had the highest grade sharp curve combination in all of California, it was not an essentially local safety hazard because other sections in the United States shared those characteristics. Part of the reason for the state's regulations was that the accident had spilled pesticides into the river. However, environmental regulation consequences, no matter how severe, also do not satisfy the definition of an essential local safety hazard. There, because the risk is not fundamentally different from other locales. And the court noted that there's over 10,000 miles of track within the United States that pass over or around important watersheds.
Quickly, because we're behind.
Sure. Finally, the requirement that the railroads adhere to internal operating regulations did burden interstate commerce because they would have to follow those California regulations even in other states. Very quickly in Duluth, the same thing. There was a regulation to lower speed limit within a town, but the court overruled it because there was no essentially local safety hazard. There, the court also said that proximity to a lake was not enough because, again, this is not a local, a unique local hazard. And none of the 5 factors that were present in Chicopee applied in this case.
Okay, now turning on to the, there's going on currently the DOT Pipeline and Hazardous Material Safety Administration does have an ongoing rulemaking with respect to increased shipment of oil from the Bakken field, and just to quickly cover what they're getting into here, a lot of this has to do with this high hazard flammable trains, which are include trains carrying crude oil, but a lot of it has to do with proper classification and characterization of the cars to let people know, both law enforcement and crews know what's in the cars. Currently, the definition of an HHFT is a train with 33 or more Class 3 flammable liquid cars in it. They want to reduce that to cover any train with 20 or more cars. And basically, these rules are targeted at unit train shipments of ethanol and crude oil, and that's the principal commodity that triggers these concerns. Let's see. We list here all the proposed changes. Most of them have to do with notice to first responders as well as speed limits, and there are a number of speed limit proposals to slow these trains down a little bit. 50 miles an hour is a pretty high speed for a freight train. I think some railroads run at 60. I believe the PUMSA requirements would now be 50, and then there would be 40-mile-an-hour restrictions in these certain areas. And a lot of the debate on these regulations has to deal with where that 40-mile-an-hour or a even slower 30-mile-an-hour speed limit should be applied. There's also concern about where electronic controlled pneumatic brakes should be required. And this is a new concept, not widely in practice, but as I mentioned before, the existing braking system is the Westinghouse air brake that dates back to the 1860s and hasn't changed a whole lot because it's pretty effective. But basically, the brake pressure is set by the engineer reducing or making an opening on the brake line up in the locomotive, letting some of the air out of the system, and it sets the brakes, but it takes as long as 2 minutes for that pressure reduction to reach the rear car of a 100-car train. So the front brakes are going on slowly, and the back brakes don't go on for as much as a minute or two. The ECP system would have a radio device on each car that would be activated when the brakes are set from the engine would cause all cars in the train simultaneously to have a port on the braking system open to reduce pressure and set the brakes. So you get instantaneous application of the brakes on all cars, whether the engineer is slowing or if he puts it into the emergency braking mode, which immediately sets the brakes on all cars, and it would release all the air in those cars and set the brakes much more quickly. The effect being that if you do have a pile up, a lot fewer cars will keep running up and jumping onto the pile after the brakes have already been set. So here we're covering the League's comments on these changes, and I think most of you know what these are, but we've just highlighted them here. It's more information and notice to first responders, better funding and training and equipment to deal with accidents, and requiring oil spill response plans to mitigate and minimize accidents and deal with the risks and consequences. The League has also advocated a maximum speed of 40 miles an hour in all areas for all transport of Class 3 flammable liquids. That goes beyond the DOT proposal. And the League has called for more study to ascertain relative risks from transporting 20 or more Class 3 tank cars compared to trains carrying fewer cars. As I noted before, the typical unit train is all oil, and it's probably going to be 75 to as much as 100 or more cars behind a single locomotive. Just quickly, this is a list of recent state legislation and activities in California that was covered in detail by Tim in the part 1 of the webinar. But as you can see, most of this is in the area of spill response and regulatory accountability, recommendations on DOT policy, not much there having to do with physical changes on the rail line. Another quick subject to cover is the RSIA, which is the Rail Safety Improvement Act of it's actually, I think it was, this is the new one. The RSIA was originally passed in 2008, and that earlier version of it called for implementation of another regime called positive train control. That's not in the 2014 bill, but it's actually already in the 2008 law. Positive train control is quite an advance. It's basically a GPS-type device that would be on trains on main lines on which passenger trains operate, or hazmats that have an inhalation risk. That would be corrosive and toxic materials such as chlorine. And the idea is that you have electronic devices on the trains. The computer system monitors where the trains are, how fast they're going, and what opposing moves are coming. It's designed to intervene to prevent a train-to-train collision or a derailment because a train is running away at excessive speed above the track regulatory speed limit. Although this called for implementation by the end of 2015, I'm told the railroads are behind schedule and just physically will not be able to get that implemented within that time frame. And there's a lot of information about that on the American Association of Railroads website. The 2014 Act covers regulations that would apply to these high hazard flammable trains and tank cars. And it is intended to be a stopgap measure, and then the railroads can adopt their own methods for prevention plans and dealing with first responders and so on and so forth. Again, it's largely informational, not a lot in there dealing with the railroad infrastructure. There are calls in there, again, for reduced speed limits on certain types of trains in certain areas, dense population, specialized hazardous area. And then there's a call for improved equipment involving the end-of-train device and electronically controlled pneumatic brake systems. Then to wrap up on that and get to our final discussion topic, there we go. The Act requires the DOT to conduct accident analyses and assess how the safety risks of transporting these products by rail changes over time and by location, likelihood and consequences of accidents, and mitigation features, including, well, you can see there, reduced speeds, improved braking, improved car crash worthiness, better informed emergency responders, and so on. So that brings us to the final piece of this, where we want to talk about what cities can and can't do. And I'll just kick it off by noting the preemption limits cities greatly and presumes there's going to be a uniform federal system. So obviously the first and path of least resistance is to seek voluntary arrangements or agreements with railroads running through cities. There are a number of just basically bilateral agreements out there where if the railroad agrees to adopt certain measures or speed limits at special locations, that they do that. The second path, best path to do it is just simply to lobby for federal legislative changes and regulatory changes, because the federal law prevails and preempts the state law. Going it alone, coming up with city and state regulations is the third option. Based on the analysis of the cases, I'll turn it over to Fareed to go through what the possibilities are there.
Sure. The most important point here is that care must be taken to identify essentially local safety hazards. That means that the regulation can't be statewide or really even citywide. It would be almost impossible to pass, for example, a regulation limiting the speed of a train through Los Angeles or San Francisco or even a small town. The best thing to do would be to identify those particular sections or particular a turn or curve where a danger lies. And finally, the regulation can't burden interstate commerce. This means that it can't require railroads to do anything where they would really have to do the same in other states for efficiency purposes. For example, the adoption of any particular mechanical or equipment. It can focus, for example, on track maintenance because all trains will use that track in California, but it wouldn't affect, for example, a train in Iowa. So those are some of the factors to keep in mind.
I think looking at the cases where the courts have allowed cities and localities to regulate, as Fareed said, it needs to be very specific and local. For example, a rule that calls for a lower speed limit would have to be phrased as something like from the Main Street crossing to milepost 16.1 west of the curve beyond 14th Street. You know, some specifically designed stretch of track rather than through the entire city, or you know, you also see regulations that have to do with setbacks and distances from specific facilities. You know, for example, if you had a school, hospital, extreme high density population area that was very close to the track, something that's peculiar to that area would have a better chance of standing up than something that's just generic or widespread. And then focus could be on things like track maintenance. One thing I've always wondered about is whether one could call for a certain stretch of track that has a lot of derailment hazards, such as crossing tracks where there's a diamond where another railroad crosses this track at an angle. That's a favorite spot for derailments to occur because the cars have to bounce over that irregular piece of track, or where there's a lot of switches and switch frogs. You know, for example, calling for heavier weight of rail through there, or welded rail, or more frequent inspections. But I mean, the typical major cause of derailments, sometimes you can't even prove what did cause a derailment, but they're usually broken rails, bad rail joints, badly maintained switch frogs or diamonds where the trains bounce through there at high speed and the physical forces cause things to happen. And preventing that, it's also not just a question of speed. As I was mentioning before we got on, I recall unit trains on the railroad I worked on they were all 100-car specially designed hoppers for delivery of coal from Peabody Mining to a power plant in Michigan. And these big cars were brand new, right out of the factory, but they had a strange harmonic relationship with the rails because of the 39-foot length of rails and the length of the cars and the wheelbase. At 16 to 18 miles an hour, they would start rocking back and forth violently, and we would get tip-overs and derailments at that relatively low speed, whereas we never had any running 30 or 40 miles an hour. So speed alone isn't the determinant. It's probably everything. But again, the bottom line is any go-it-alone local safety or environmental regulation is going to have to be very specific to unique circumstances pertaining to a particular stretch of track and conditions there, and not some overall or generic proposal. I think that brings us to the end of our prepared remarks here, so we can go into some questions here. Tim, did you want to make any other comment before we tackle some questions?
No, go right ahead.
Okay, I've got the first question I see, and I don't know if there are others in the queue. It says, when hazmat oil is being transported, does the information communicated to first responders include not only the type of hazmat being transported, but the standard of tank the hazmat oil is being transported in?
No, I do not believe so. The regulations require the tank car to have markings on it, legible markings on it saying what kind of car it is, for example, a DOT 111. And the train crew must have information on the type of hazmat, the classification, for example. But I don't believe that right now first responders get to find out what kind of tank was derailed.
Let me look back at the proposals here. I know that there's a lot in these proposals and the pending state legislation dealing with notice to first responders, and I think it's definitely designed to greatly broaden that, but I don't think any of it goes to that level of detail.
Yeah.
This is, Tim, one of the proposals that we believe our research uncovered. The State Office of Emergency Services has called for an upgraded uniform standard in terms of the tank placards. And those are the little diamond-shaped signs indicating what's in that tank, what the flammable temperature is, et cetera. And so that information in terms of the type of car could very well be included on the placards.
Right, so that would enable the crew to see, if they go back and look at the car, what's in it. But I guess the question is, we'll deal separately with the train crew, and then secondly with first responders. The proposed regulations and the policies called for by the league include notifying first responders when these trains are going to be moving. I don't see anything in there that would give first responders that kind of detail. But I think the other thing is that, right now all these notices, both to the crew and first responders, only would say there's a train of crude oil that has more than 20 cars of crude oil that's going to be coming at this particular schedule. But as we've seen, there's a great variation in what crude oil is. and it could be relatively stable and low hazard shipment, or it could be an extreme high hazard shipment depending on what's in that particular batch of oil. And they would not know that. They could presume, I guess, that the cars that are used meet the minimum federal railway standards, but whether they're one of the older cars that hasn't been retrofitted yet or a brand new one, nothing in there along those lines. And you know, perhaps that would be very useful information for them to have. But again, it would be probably secondary to just the information that they will be getting, which is that this particular train is coming and how many cars there are and where they are in the train. Okay, I don't see any other questions there now. Does anyone want to?
Well, I've got one. This is again.
Okay.
There was a reference earlier when talking about the case law to unique local safety hazards. I believe the reference came up in the Duluth case. Has that term ever been defined, either in regulations or by the federal courts?
No, certainly. I'm sorry.
Yeah, just what constitutes a unique local safety hazard? Have they given any guidance on that?
No, it's certainly not in the regulations, and it's not in the statutes. So the different courts have grappled with it. It hasn't been looked at by the Supreme Court yet. So the 13 different circuits have looked at it, and they've all kind of relied on each other just to say what it is. And it's what we said in the case about something that is particular, that has characteristics particular to that location, which is not duplicated either statewide or nationwide. Something that requires regulations that cannot be promulgated nationwide to solve that hazard. That's the sort of language they've used. No court has come out with a singular definition that would be applicable in all circumstances.
Okay.
Okay, we've got another question here about how do local agencies determine which rail lines, if any, within city limits are being utilized by the railroad to transport hazmats in general. And Fareed, under the PUMSA regulations, is there anything that comes to mind there as to general notification?
For which rail lines in terms of which track?
Yeah, let's say we don't have something that rises to the level of a crude oil unit train, or the 33 car plus, or the 1 million gallon limit that triggers the one notification requirement. Let's say a railroad just has a train going through a city, and there is 1 tank car of hazardous chlorine, and then 2 tank cars of crude oil, and then maybe another tank car of some other corrosive material. Is there anything that you're aware of in the regulations that requires them to notify or respond to any questions about whether they're transporting those types of materials through the city?
No, not right now. I know there's higher, the most stringent requirements are for noxious gases, which are a higher level than crude oil, a gas that, if released, can injure or kill someone. I think those might have a higher notification standard, but I don't think right now there's a general notification standard like this.
I was just trying to skim through the proposed legislation. I think there were some measures in that list of proposed bills that Tim put on in the first seminar that started to reach those issues. And if you'll just bear with me for a second, I'll see if I could find that. I can't remember. I thought I saw something in the California PUC policy proposals.
What was it again?
Yeah, Well, what I'm looking for, Tim, is in your detailed descriptions of the state, the pending state legislation in California and the California PUC proposals, whether there's anything that requires notification or information to be given to the cities just in general about what hazmats are moving through the cities. And
the only thing I'm aware of is the unit cars of 100 or more. That information goes to the, and I think the OES, the Office of Emergency Services, and that threshold is generally arrived at when you have since it's 1 million gallons, that's approximately 33 tank cars or more. The OES has recommended lowering that threshold from 33 cars to 20 cars, but regardless of what the threshold is, the CERC is notified. When they're notified, the OES automatically gets the information because the OES personnel are staffing the State Emergency Response Commission. They then distribute that information out to local agency first responders, just in advance on a proactive basis. But anything below that threshold, there is no proposal I saw to alert local first responders. And that's an issue that may be dealt with by the league in its formal policy recommendations, which are still pending.
Right, and then I think what the question is going to is an even more detailed issue of when do you know, or how can you know, if at all, what a railroad is moving through your city, other than you know standing there and looking for the cars with the placards on them that might give you a certain bit of information. But you know the railroad's manifest and the contents of those cars are proprietary information, and I doubt they give that out. But anyway, I'm not aware of any method by which a city could obtain information on a car-by-car basis, or even in general, as to whether a railroad ever moves any specific types of hazmats through the town, because as long as they follow the federal regulations, they would be free to do so. And if they're below the 1 million gallon threshold, there doesn't seem to be any current notice requirement at all.
Our research indicates. Go ahead.
Oh, go ahead. I was finished.
No, I agree. Our research indicates the same thing, but I will research with the Office of Emergency Services whether there is any mechanism by which locals can get that information. Currently, our understanding is that if it is not specifically required, a specific notification requirement under federal regulations, then companies do not have to give that information.
Right.
We'll confirm that.
One thing I would suggest is there are a lot of consultants in the space, and most likely if a city wanted to determine what hazmats are moving through tracks and right-of-way within city limits, you could hire one of those consultants, and they could, through various means, probably figure that out fairly accurately through various means, including just sitting there and watching what goes by. But again, that would be an estimate, not hard information from the railroad. Okay. Don't see any other questions teed up, but are there any verbal questions? Anyone want to put their hand up?
This is Tim again. I had yet another question on the early in Fareed's presentation. He mentioned Class 3 flammable liquids, and that encompasses Bakken crude. But I wonder if there's a general definition of what a Class 3 flammable liquid is.
Yeah, it's
Fareed's getting the reg out. I believe it's based on what the flash point is in Fahrenheit temperature.
Okay.
And you know that
it's a detailed chart. I don't think I have the chart with me, and it has to do with the chemical's volatility, also its toxicity. Unfortunately, I don't have it here with me. Yeah, I can certainly send this to you after the presentation.
I know on the PUMSA side, because I've done some work recently on ocean shipment of vehicles that have fuel and other hydrocarbons and compounds in their fuel tanks or cargo space, that generally what they look at is the flammability is just an index based on the Fahrenheit temperature at which at sea level or standard barometric pressure, the liquid starts to give off fumes or gases that can be torched by an ignition source. So I know for gasoline, that's generally 40 degrees, I think, and diesel is a lot higher. I think diesel is way over 100 and so on. But I know the Bakken crude is way down there. You can set that off with a spark at a fairly low temperature.
Okay, and that kind of information, for those who don't know, is the kind of information that would be included on the placards on the tank cars themselves.
Mm-hmm. And that just would tell you that what class the material's in, you know, and it's like an on-off switch. It's either going to be in the class or it's not. It's not going to tell you this one is twice as dangerous as the one next to it. You know, you could have one cut of cars in there with Bakken crude that's got a lot of distillate and condensate and liquid or you know, natural gas liquids like ethane and butane in them that are highly flammable and easily ignited by a fairly remote flame. Then another group could be heavier crude or Bakken crude that's had those materials taken out of it before shipment. And that's one of the proposals I think that I've seen is that that this Bakken crude should be processed at origin to remove those natural gas liquids which make it so highly flammable.
Also for the shippers to sample. The shipments and get accurate readings of exactly what they are.
Yeah, and I think that's going to be very problematic because that involves an awful lot of physical work, a lot of science, and a lot of costs and reporting. But I know I've seen it I think that may be in the CPUC proposal as well.
Right, and there are also issues with disposal of that liquefied natural gas or other material that's removed once it is extracted. What do you do with it? And if you've got to transport it, then again, how's that transported?
Yeah, well, that's very valuable stuff. Actually, interestingly, in the hydrocarbon pricing world, the liquids command a much higher price per BTU of energy content than gas does, and those natural gas liquids markets are very volatile, but there's an awful lot of revenue there, and so that material is going to go somewhere. Now, things like condensate or distillate may ultimately be backhauled up to Alberta, to the oil sands area, because they need it to dilute that oil sands heavy crude and the bitumen so that it can be transported by pipeline if they ever build one. But anyway, yeah, that's a good point, because if you remove those highly explosive materials, then they're probably just going to move in a different tank car right next to the crude anyway, and
there's not enough pipeline.
Be even more dangerous. But they may be in a higher hazmat category than the crude oil. There are higher. The class 3 is one of 9 classes, I think, and they may just fall into a higher one that calls for even higher regulatory standards. Okay. Again, I don't have any more questions teed up, Tim, and it's 12:15. So if there are more questions, we'll be glad to answer them. Or if anyone wants to send them by email, we could respond to that as well.
Okay, well, let's give it another minute. I will share the details of the next webinar. That is going to be Thursday, November 6th at 10 a.m. During that webinar, we will share the details of the National League of Cities resolution on this issue, which is, there's going to be discussion on it when they meet in late November, in, I believe, early November. And at that point, we will also have the League's formal policy recommendations, which will hopefully allow our members to fine-tune advocacy efforts that they already have underway. Okay, well, if there are no more questions, I guess we'll conclude this webinar. Thank you all very much.
Thank you. It was our pleasure.
All right. Take care.